Welcome, mathematicians. It's Professor Pandemic here once again to talk about dividing by two-digit divisors. Today's lesson is dividing a four-digit dividend by a two-digit divisor. So in this problem, we have 8,325 divided by 20. I'm going to take this a step at a time to show you that really, no matter how many numbers you have, it's the same step over and over again. So we have that 20. We have to look at each digit first. So the first number I'm going to look at is 8. Now, if I have 8 dots, there is no way I can make a group of 20 out of 8, obviously. So that's why when you're dividing by two digits, a lot of times you're going to have that 0 over the 8. Now, really important to have that 0 because notice how there are 4 digits here. There should be 4 digits in our quotient, and that placeholder, 0, we really make sure that we don't divide an extra time if we don't need to. So now, we go to the 3. Because we have 20 there, really easy to skip count because there's no number here in the ones place. So I look at this 2, and I look at this 8, and I skip count by 2s. 2, 4, 6, 8. So that means I'm going to put a 4 up here over the 3. I now multiply 4 times 20. That gives us 80. 83 minus 80 is 3. Notice our subtraction is smaller than our divisor, which means I can then go on to the next digit in our problem, which is a 2. So I'm going to put the 2 here. We bring down the 2. And now we repeat the same process. Skip count by 2s to get close to 32. Well, we only have to skip count once for that. So the 1 is going to go there. Same step. 1 times 20 is 20. We subtract again, which gives us 12. 12 is smaller than 20. So that lets us go to our last digit, 5. And notice if you've been writing everything correctly in your quotient, notice we only have one number left here to bring down. We only have one number left here. So now because it's a 3-digit number, I look at my 2, I look at my 12, and I skip count by 2s. 2, 4, 6, 8, 10, 12. So that means I'm going to want a 6 up here in my quotient. 6 times 20 is 120. We subtract one more time, and we get a remainder of 5. So 8,325 divided by 20 is 416, remainder 5. As you notice, you just take one digit at a time and you keep going throughout the entire problem. Let's do a couple more examples just to make sure you're ready to go with this. So for this problem, we have 8,327 divided by 30. So let's take it step by step again. 30 can't go into 8 at all, so we have our 0 here. Now we look at the next 2 digits because we only go one digit at a time. So it's 83 and 30. If I skip count by 3s, 3, 6, 9. If I put a 3 up there, I've gone too far, so I'm going to stay with 2. 2 times 30 is 60. And we get 23 when we subtract. Always make sure when you subtract that it's smaller than your divisor, your outside number, before you bring down the next digit. I'm just going to change markers really quickly to show that we've gone to the next digit. Now, because 232 is such a big number, I look at 3, and I look at the first 2 digits here when I skip count or estimate. 3, 6, 9, 12, 15, 18, 21, 24. So 24 is too big. I'm going to stick with 21, which means I'm going to put a 7 up here. 7 times 30 is 210. I'm going to erase my estimating marks. We subtract. 22 is smaller than 30, so I can bring down this 7 one more time. And then we have one more step. Now what's fun about this problem is notice right here, we've already kind of multiplied, so I can use information that I already have to see, oh, 210, 227, that's pretty close. I can't get much higher than that, which probably means I'm going to use a 7 again. 7 times 30 is 210. And that gives us a remainder of 17. So 8,327 divided by 30 is 277, remainder 17. We're going to do one more problem together, and then your teachers will probably do a couple examples with you in class. Our last example is 4,328 divided by 60. Now this problem's a little different, and we'll see why in 1 second. 60 still can't go into 4, so we still have to put our 0 there in the thousands place. But notice here, it also can't go into 43, which means you're going to have a second 0 before you even start dividing, which sometimes happens when your divisor is a much bigger number in the 60s, 70s, 80s, or 90s. It can happen when it's smaller, but it's more likely to happen when the number is bigger, which means we're looking at 432 to start with. Well, you still do the same thing. You look at your 6, you look at the first 2 digits here. I just cover up the 8 because we haven't gotten there yet, and we skip count by 6s until we get to 43, or close to 43. 6, 12, 18, 24, 30, 36, 42, 48. 48's too big, so I'm going to want to stick with 7 again. 7 times 60 is 420. Erase your estimating lines if you use them. That gets us 12 for when we subtract. 12 is smaller than 60, so we bring down our 8. Skip count by 6s again until we can get somewhere near 12. 6, 12, well that hit right on the nose, so we can use a 2. 6 times 20, or 2 times 60 is 120, sorry. And we get a remainder of 8. So our answer here for our quotient is 72, remainder 8. Notice in all 3 of these examples today, they all end in 0, which makes it automatically able to estimate. As you'll see here later in the week, or if your teachers start doing more problems, you might start getting numbers that don't end in 0, which means you have to estimate, and when you estimate, the numbers might not come out as smoothly as they did today. We'll look at those with some other tricks probably in a couple days, but for now, I'm Professor Pandemic, and happy dividing, friends. We'll see you in our next video.